Hello, it's Dr. A and welcome to the back office. Your eyes do not deceive you. This is the Retro Electro scale Megadrive model. However, this video is not going to be any passive video. We're going to turn this into a real fire-breathing Megadrive that does all you expect. The switches will work, the cartridge will work. It's going to be split into two parts. The first part being the hardware required and all of the fidgetry going on to make that work. And then the second video is about the software. So watch the first part for the hardware, the second part from the software, and after that you can make your own and play it. Hi, I'm Andrew Armstrong and welcome to the back office teardown lab. Today we're going to be working on this SEGA Megadrive scale model by Retro Electro. That's retroelectromodels.com. And I'm going to see how to turn this into a working Mini. So you're all used to the PlayStation Mini and Super Nintendo Mini and NES Mini. I think this is a perfect candidate for turning into a Mini Megadrive. Or Genesis, let's be fair, or Genesis if you are from that part of the world. And the idea is to see if it's possible to get some of the stuff working. You know, it's easy enough that we can hook it up, I'm sure, get a Pi in there and get it to work. If we can get some of these functions working, like the on-off switch or the volume, I think that would be cool too, or LED. There's lots of things, and also the cartridge. So to do that, we're going to see, as a sort of systems engineering approach, how to install either a Raspberry Pi B+, or is this an A? An A+, I mean. You know, you can see it's basically the same thing, minus the Ethernet port and all of the USB ports, so it is that bit slimmer, so that can often fit where this one can't. And I do have two flavors of RFID receiver and two flavors of RFID chips, for lack of a better word. Whether or not these are possible to use, I don't know, because you can imagine if they're in the cartridge they'll be mounted vertically, and I don't think the readers generally respond to vertical things. I do have a big selection of tack switches, so it may be possible to tack up some of these, so we'll have to work out that approach there. And if we've got a slider, and because this LED is so tiny, we might have to sort of drill that out and kind of make our own fake LED, or at least a channel to a real LED, but like out of a bit of fibre optic or something like that. So first things first, I've already removed the screws because I had a little sniff around inside, and there is a nub in here which is kind of annoying, and there is a whole cartridge mechanism. So yes, they have put the effort in of making quite a nice cartridge mechanism. It almost has this sort of slot in the middle where you could even have a PCB edge connector. So I think electrically we could probably make a cartridge with some metal contacts basically on the cartridges themselves. So depending on the binary pattern they're pinching out, it could switch on that. So that could be an easy approach. But if the RFID works, then that's fine too. So first thing, we're going to put the Raspberry Pi A+ in there, and you can see it's being kicked up by that nubbin. I think that would be the best way around though, so you could get the HDMI port out. Maybe sacrifice one of these screw lugs if you really want it to fit. In fact, that's really good. If you're happy to resolder your USB port, that would be pretty easy, or just offset it and put a 90-degree USB port, and then we can pop that lid on. Oh, look at that. That's damn close, isn't it? I mean, that is damn close. Already you can see we can get that in there. And then what else would we want? We'd want the LED, which we could use for some GPIO. We can always get the LED working, that's not a problem. And then the feasibility of trying to get some of these volumes and things, those are going to be tricky. We'd have to work on that separately, really. I think my plan of attack would be to fit that first. And then, if possible, we could put some micro USB ports on here, so you can actually just plug in a micro USB controller. Although I think most people these days will probably just use Bluetooth. 'Cause I don't know about you, as much as I love the SNES Mini, I do not love having wires in my life anymore. So I think rather than mess up this quite nice looking effect. I mean, that has a nice looking effect there. Maybe I think Bluetooth's the way to go. So first things first, let's get rid of this nubbin because it's kicking up everything. We can't really measure anything until that's gone. And just to remind you what that is the stand lug. So if you've got the stand there, that fits into the bottom there. So after you cut that out, well, let's have a look, see what happens. So we got our little drill thing ready to go, and of course now safety glasses. I'm very, very safety conscious in these videos, but yeah, if you've got them, use them. If you don't got them, go buy some. So I'm just going to work this and get it out. So I've got rid of that now. You can see it's quite a nice finish really, if you take a bit of care. So if I take the stand now, we can see how that would now fit. Clip that in. You can see you've just got probably about a millimetre protruding, which I think you'd be able to sand off that. So if you just run that under a sort of sander and just trim that down a bit, you'll still be able to use the stand when you're done. So that's nice, isn't it? Let's have a look, see how our pie is going to fit in. So pop that in like that. And the lid is pretty much there. So you can hear it's not rattling around. So it's well, it did then, but it's definitely pinched. But it is fitting. So if you look at the back, you've got the HDMI port alignment. It's a bit too far that away. So if you do want to fit this, you're going to have to try to remove this or modify the PCB. So let's have a look at an A+ PCB here. See what we can see. There doesn't appear to be much going on in this corner. I think we could almost just cut that out. But before we do, let's be sure. You've got one trace here going to this headphone socket, which goes to this side of this capacitor. But apart from that, there is just sort of ground plane with a via punching through both there. Not sure how many sides, how many layers this PCB is, but certainly there's not going to be anything going on there. So you can take out this corner. So we'll pretend we have for now, and then you can see there's more than enough room for our HDMI port. Imagine it's just right there. You're going to be slam dunk right in the middle. And then the only thing to worry about is maybe this pin header's using a little bit more space than we really want it to. So what I'm going to do is I'm going to take this out and quickly have a go at it. Let's have a look at this Raspberry Pi B+ though. How feasible is it to fit? So you might just have one of these lying around. Let's just try to fit that real quick. With this plastic bit in here, there's no chance. So I'm just going to remove that anyway. I'm sure you're all wondering. I'm going to probably go ahead with the A. But if you've got that B+, you'll be itching to know. And of course you do have those other variants. You do have the little Raspberry Pi Zero, I think it was called. I've used it before in projects, the little tiny one. I mean, that's almost guaranteed to fit anywhere. Ooh. So yes, if you are curious and you want to use the B+, you can fit that in there. The chances of hooking up your HDMI though in an attractive way, or at least a way that sort of is sympathetic to the case design, is not going to be so easy. What I would suggest though, let's have a look. If it's no chance it will go that way, is there? Oh, yes there is. So you could fit this that way. I would suggest then shunting this all the way to the right. Have a look. Shunt it all the way to the right, or pretty near. There's actually a hole in the case here that's manufactured right through there. I would open that out a little bit and have an HDMI wire coming straight through, one of those nice slimline HDMI wires, plugged straight into the HDMI sockets. You could just have it hooked straight in like that. But apart from that, I wouldn't advise. If you're going to buy a Raspberry Pi, I mean, let's say by the end of the process, if it does everything we need, I think this would probably be the one to go for, the A+. I decided that before going any further, I was just going to start playing with all the pieces. So I've been having a feel with all of these things, and I've decided that the LVDS header here on the Raspberry Pi A is going to get in my way. So I've decided to try to remove that, and I'm just going to use a soldering iron probably than hot air right now, because I don't want to break our Pi board. I think this could be potentially the safest way of doing this, but yep, I can feel it coming. Because it is quite close to many other components. And there are some very fine dust-like components on the Raspberry Pi board these days. There's always the other option. Actually, I'll show you another way of getting this off. And that's kind of nasty, but it's coming off, it's coming off. Just taking some side cutters to it. Get as much of the parts off that you don't need, like that. You can see we're still taking actually quite good care of the board underneath. And then you can use your soldering iron just to lift the remaining components, hopefully without damaging the tracking on the PCB. So make sure that you get plenty of solder and plenty of flux in there, and give it plenty of heat. Just take your time. It will come up, I promise you. It's the moment of truth. I think I'm going to settle for putting it in this way. So I've removed that LDVS header, and you've got to be careful. There are some wireless components here you might nom. Try not to. And in order to do that, I think what I'm going to try doing now, I'm going to do some whittling before I take this panel out, to sort of cut it out, which is kind of irrecoverable, which is kind of a shame because it says RF out and it's got all the markings, but at some point we need wires to be able to get into this damn thing. So you can see it's possible to mount this in that same hole. So what I'm going to be doing is whittling this down so it's a little bit shorter, and I might just run this on the sander a bit, just take off any excess. It doesn't need to be that deep for our use, and if we can get that down a little bit, we'll get an extra mil off this, which means this will sit higher up here. There will be a rebate, of course, though, so it's sitting back. It's not pushed right out, but I do like the idea of sitting it back slightly because it does give us just that little bit of breathing room around the unit. And I don't think, from the back it's not going to look stock anyway because of an HDMI here, and it does give us the opportunity to sort of work out what to do with that afterwards. So I think I'm going to take this off, sand this down, come back, and let's see, once this is fitted, how we're going to attack this part. So I've modified the case. I've taken that down a bit. You can see this is all very rough right now. These are rough cuts, but I'll smooth those out and do them a bit finer if you're doing them yourself. Now you can see these have little bits cut out of them for the top threaded sections to sit into. You want to remove that flush. I'm almost flush there. You can see I've left a few little nibbles to attack there, and just be a little bit gentle because on that corner there's a little bit of plastic that if you touch it like I have, you'll damage it, but that might not be an issue. I suspect it won't be because we're going to be hiding that. Now what I've done on this side is I've sanded this right down and then sanded another section here. You can see from the sideways profile it is stepped, and the reason being we have componentry here that this follows the step now. I've chopped out the threaded section here, and I've actually put in a standoff, which you could get from most motherboard type boxes. If you bought a PC motherboard, you normally get a bag of these sorts of things, and you can use some of the fittings on that one. And I've basically tuned it up by screwing it in and out so that when I put this board in this way, which is actually the correct side, the correct way up for the Raspberry Pi, it'll sit just on top of there and sit quite nicely within that section. And what you can do is you can screw that in and out to tune it, and you'll know you're about right when you get the lid. You can fit that just like that, and I've got here just a little wood screw for now because I haven't got quite the right machine screw. You can pop that in there gently, and if you're lucky you can see in there's the board. It is closing nicely. It is actually reasonably well sealed. I won't force it because it's not the right thread, but so far so good. Now the next big decision is how to cut the back, and I have to admit I'm no expert on making rectangular holes in things. The ideal scenario would be just to literally cut out only the HDMI port. And if you want the headphone out, which actually aligns kind of with this AV out adapter, which is kind of cute. Well, I've decided, by the way, for the power as well, I think I'm going to have a permanent power coming in on this, and I'm going to solder it in here to this USB. I don't think I'm going to mess up the case to cut that one out. So I'm going to attempt cutting this out, and the way I'm going to do that, I'm going to get a micro drill, and I'm going to just drill a bunch of small holes and hopefully try to get them into one bigger hole. If that fails, I'm not too worried. What I suspect we could try to do is run a knife along here and just take out this whole panel, and then figure out a way of replacing this panel with something else, you know, a bit of plastic, and then we can sort of cut that on the bench and then put our new piece of plastic in there, and then that will slide in nicely to there. So lots of options. I'll go try to make that hole now, and then we'll take it from there. So I've pretty much just by eye worked out where I think this port's going to go, and I've marked it out. It's a little scrapey scrape. So what I'm going to do is use this very fine drill bit from a micro drill bit set, and I'm going to put a series of holes on the extreme sides, and then I might use a more aggressive tool afterwards, but knowing hopefully it won't go through where I've drilled these small holes, so it's a bit fussy. And you've got to remember the HDMI lead, the plug on the end of the lead, is a bit thinner normally than the socket, so hopefully it should just slide right in. But I guess we're going to find out soon enough. It's very hard to have a nice straight flat edge though, so don't feel bad if you don't achieve one, because I know from experience it's one of those things that eludes a lot of us. And if you haven't got one of these, I suggest you get one, because they're really quite handy dandy tool, and it's pretty quick. Every time you hear it sort of making a sort of snapping sound, that's the spring forcing the drill bit straight through the plastic. And you can see we've got a few holes there. Wouldn't take long really, would it? So I like to just put one on each end, and then put one on the middle, and then put one in between that, and until you're just dividing it down halves, quarters, eighths, sixteenths. Keep going until you get bored. The more you can do, of course, the nearer you will be, and the smoother your final HDMI hole will be. Now if you want to do a really nice job, do it on this edge as well. I know you've got this plastic edge, but when you're trying to run a grinder or a little grinder, something like that, up against that, you'll easily go through that. So yeah, holes on that edge too. If you've got a very small Dremel, you could use a Dremel to do this, but just take care. It's a little bit of it's an unwieldy tool compared to this, so you might not have the accuracy. The hole is made! So I just ran a little file around it after I basically drilled all the holes and had a little pokey, and you can see it sits there quite nicely. I've got the Raspberry Pi running a noobs system here just to make sure it's actually all working still, despite my efforts to vandalise it. Just to show you how it all goes, you take that there, you've got your slot here, and then that will align nicely. You can see I'm aligning it with the screw hole, and then if we zoom in again, more or less there. Remember, there's a little bit of movement here until it's all in its case, but you can see it aligns quite nicely. And then you can take your HDMI, and I'm just squeezing it here with my thumb because again it's not screwed down, but you can see the HDMI slides through the case and then meets up with the board on that side. HDMI wire, if you find you do this and it doesn't go in enough, what you can do is just take a little blade and very gently cut the overmoulding. In fact, why don't I show you doing that? And what you can do is basically allow the HDMI to be a bit longer reach. And it is the case though with a lot of HDMI wires. There is a variance in these. This is an Amazon Basic, and I'm cutting about 2mm off it easily. Easy, nice clean 2mm. You can see that there, straight off. Boom. Slightly long, and it's up to you if you want it to be a bit prettier. I suppose if you could carefully pair it and make it pretty. But you can see in there, actually, that plastic in there, that's the hard overmoulding that protects the HDMI. So you're just cutting off some of the rubberiness. And then if you pop that through again, you'll find that extra couple of millimeters allows it to really sit firmly home. And in fact, let me just, I'm pushing it right through so you can see exactly how far there. And if you look incredibly closely, right there, you might just see, just in there, a line I've scraped onto the HDMI just to show you when you push it in outside the case how far it goes. But I have already validated this. It does work. I mean, it's got a tolerance between there and about there on this, so anywhere in that range it works fine. So once you've done that, you've basically pretty much got a working unit. The only thing I'll need to show you is how to wire in manually the USB to here if you don't want to make another hole. If you want to make a headphone hole, you're more than welcome to at this point as well, and I'm just holding up to you where it'll be. It'll be round about here. You'll have to drill the hole, so you'll have the headphone hole there. For me now, I'm thinking, meh, I'm not going to do that. I don't want to make extra work for something just to prove that you can do it. We know you can do it. Now, let's go on to some of the features of the case itself. You may want to actually get some of these things working. Now, I've been racking the shelves, ransacking the boxes to see if I've got any suitable switches here and slider potentiometers for the volume. And alas, I really don't at the moment. I'm just going to tighten this up, by the way. It's sort of worked its way loose. I've been cranking it so much. Ooh, too tight. What I have got is tack switches. Now, tack switches kind of will work if you want to make this like a momentary, where you can have off and then on, and then it'll kind of bounce back a little bit, and you click it on. You know, you can push it like that, and it'll have a switch. The linear potentiometers, sliders rather, for here. Again, I've worked out how you do it. Basically, is you'd put a regular potentiometer here, and you'd have a little paperclip arm to actually act as an actuator. And as you move this, it moves the arm on the pot. Again, if I find one, I'll put it on. But I think something this definitely needs, it's critical, is the power on LED. I think we all agree it needs the power on LED. Now, you've got ways of, we can drill that, put the LED in, no problem, but you've got ways of hooking it up. So either you can hook it up directly to one of the power rails in here, so if the Raspberry Pi has power, the LED is on, which, yeah, sort of nice, but not quite good enough. What you could also do is wire it up to a general purpose I/O pin so that it's operable by software, so you could decide when it's on or off, because you remember this is like a low power Linux machine. It can be on all of the time, just eating a couple of, you know, fraction 500 milliamps or something. So it's actually only on when you want the Megadrive part to be on, and then when it is off, in inverted commas, it could be sitting there being, you know, acting as a server or something. You can decide. Either way though, we need to take out this LED. So I'm going to use my micro drill bit again, and I'm really quite scared now. I'm not sure, I haven't worked out how I'm going to actually replace this yet, so go easy. Basically, go easy on it. Just lining it up the way we want it. Sorry if you can't quite see. In fact, let's zoom in a little bit. I think you will be able to see what I'm up to. If I just already dashed the paint on it. So I would have quite liked to be centre. So I'm going to try to drift this. I like how we're trying to drift a micro drill. And look, I have drifted it. It's looking good now. Whoa! So we've got a hole. It's quite quite small. It's not quite the size that the case has got in its opening, so I do have a selection. I'll tell you exactly what size it is when we get there. I'm going to go for the next size up, which would be 0.985 millimeters. Now, say it's probably more like a millimeter hole, but we'll go for 0.95 millimeters. There we go. Welcome to Drill Bit Chat. You can see there we're really quite close now. And on the other side you just got that fine little hole. And just to show you why we're not using an LED, and I did have some very teeny LEDs somewhere, I can't find them, but if you look at regular LEDs, although these are the smaller 3mm LEDs, way too big. So what I'm going to do, I'm going to put a tiny bit of epoxy resin, just a tiny bit, and put a drop of epoxy resin on that, like a drop, little tiny droplet, and then when that hardens, we'll put an LED from underneath and illuminate the droplet. But I do think it will benefit from going again one size up on the drill bit, and that is just that too big for my little drill holder there. Just going to do it by hand. Yes, I am the man. Look, drilling that by hand, hardcore. I'm like Arnie. So now we've got that tiniest amount. Remember, you're only taking 0.5 millimeter, so you could, if you can't drill that by hand, I'd be really surprised. So the next trick is to mix up a tiny bit of epoxy resin, just to put the smallest amount on there. Make sure it's clean. Give it a blow, and get your epoxy resin out, and find yourself a bit of old paper. And if you've got an old bits of paper like that, that's fine. And you're not going to need much. So this is available in Poundland for £1. You can see there's 2 nozzles. Make sure you get a bit of each on each nozzle. And then I'm just going to mix that up. You can hardly see it there. It's nice and clear, so that should be good for our virtual LED. I'm just going to mix that up. So you can see I've got a smear of it basically. I'm hoping we don't need much more than a smear. So I'm going to try to figure out how to make this into a suitable blob. I think that ought to be about right. I say that, I think there's some dust in the old hole still, so don't want that dust to stay in there permanently. And I'm going to try to just literally let that drip off the edge. Might be better to use a toothpick if you've got one. There we go, that's it. If you can just see that, it's just literally like a little glass window over there. So I'm going to leave that for a minute while I go and have a look for a suitable resistor for our LED. So while that's hardening, I've decided I'm going to have a look at our LED. So I've got a regular LED, and I've chopped off the positive leg, which is the long leg, and I've got a resistor, and I've shortened that significantly as well. So I'm going to be bonding those together. And what I'm going to do is to make the LED a little bit more diffuse at some point. I'm going by basically sanding it flat, and then we're going to glue that underneath where our red LED goes. So this is a, what is it? It's a 330 ohm resistor. It could be a little bit too too much. Depending on your LED and how bright you want it, anywhere between probably 270 and 330 you're going to find will probably work. So that's that. Again, it will depend slightly on our input source, because Raspberry Pi's got a 3v3 rail, of course, and 5V input from the USB. So I've kind of made an assumption there that we'll be using 5 volts, but that might not be available. That's no problem though, really. We'll just change the resistor out. So I'm going to put a bit of heat shrink over there just to make it pretty. Although, maybe... yeah, I did it. I managed to get that bit of heat shrink over there. And if you don't have a hot air source, it's a bit naughty, but you could use something like a lighter and be quick about it. You want the heat, not the flame, if you can help it. And there you go, nice sealed thing. Probably benefit from a bit of heat shrink on the other side. Let's add that, just so that we don't short this out to anything. And also it means you can apply adhesives and things onto the heat shrink instead of that lead. Okay. Stay. God, I made that way too long. Way too long. Unfortunately, that araldite doesn't take too long to harden. But while we're waiting, why don't we try to hook up some power to this and see what it will look like. So I've got some hookup wires here, and I'm just turning my power supply down. It was on 12 volts. That would have blown the LED out. So we know that the resistor leg is our positive leg. Just like that. We'll turn it on. Ooh, nice. Oh, that's nice and bright. And you can see that's our nice Megadrive effect there. So I'm going to see what it will look like sanded. So I feel if I hold it on its side like this and sand that way, we should be able to get it to look alright. I mean, it's kind of a crystal teardrop, so even just sort of scuffing this up might cause the light to diffuse nicely. And if you've got something simple, like just a file, you'll probably be able to do it on the bench. And I'm going to try that right now. Yes. I assume I'm filing the LED and not the tip of my fingernail. And just hook up some power again. Lost my heat shrink. Yeah, I think that'll work out quite well. So we'll just basically glue that in there with some araldite. Things are looking a little hairy, and that's because a lot of fitting, trial and error testing has gone on. Just to show you where we are with this, our LED is nice, looks real cool. We've basically hot snotted the LED in at the back, and I actually filed it down so it was really nice and flat. And I did notice a lot of the light was diffusing that way. I'm just hooking up the LED now with our power supply, as you can see. There you go. Nice look in there. It looks really legit. It's hard to see on the thing, but it looks just about right as you'd want it to look. So what I started to do was to experiment if we could do something with a switch. The volume switch, headphone volume switch, I was like, nah, you know, it's neither here nor there, the volume level, but I was more concerned with the on-off switch here. I thought that would be nice to get that working. So what we have here is a magnetic reed switch, and I've put an niobium magnet, you can see there on there. And what you can do, it's a bit dodgy, these are very strong magnets by the way, is when you get a reed switch, if you rotate it, they become less efficient if they're oblique angle to the magnet. So you can mount one quite close, but make sure you do what I've done where you've got a buzzer so you can test that. And then once it's just working just right with that, glue that in place. Be careful though to pre-bend the lead. If you want the lead in a different orientation, make sure you pre-bend that and use 2 sets of pliers, one here, otherwise you'll smash the glass. And we're going to put some wires on our LEDs, and I have some pin headers ready. However, there's a reason I might not be using this. So one of the other aspects of this I thought would be neat would use RFID to identify the cartridges. So RFID tags, look something like this. And there's 2 types here. So there's 5 in this kit because I've already broken one. And the idea is you would put the tag in the game and then the game would work in the reader. Now I have tested the reader. So this is an SPI reader, SPI. Actually, I haven't tested this one, but I have tested this one. This one is a USB one. This one is really cool. This one basically connects at USB, and when you pling it, it's as if you typed in the number off the RFID. So that one's nice and simple to integrate. This one is going to integrate onto the SPI bus. Now, it doesn't look like we're going to be able to use the USB one, and all of its loads of keys. We have to use the SPI one, and it's single one. So it might be a bit dodgy for me to break this one apart because I don't have too many spares. In fact, let's have a quick look inside, because you can get to it. Normally what they are, I say normally, I've only done one and I broke it in the process. It's a coil for powering the device plus a little chip. Oh yeah, cool, there we go. So you can see that right there. There's a coil on the outer and then there's a little chip on the inner. And I'm just looking desperately on the shelf for the one that I broke earlier because I threw the coil away, but I'm going to zoom in. You can see it is using, it's weird. I tried this dongle on the other thing and it didn't work at all. So although the chips look the same, there's just 2 wires there. They're obviously not compatible. And I think the reason they're not compatible is to do with this antenna, because this looks less dense than the other one. And you can see from the PCBs, this has got a massive antenna both sides, whereas this one's got a very simple one. So maybe they're just more of a frequency thing. Now, the problem is, as I said, you can't use these devices, it seems, at an angle. So if you touch it like that, it won't pick it up. It has to be flat. So it basically has to act like a transformer, and it has to be overlapped onto each other. So I don't think that means in our cartridge it's going to work when we pop our cartridge in the slot. However, we have just about enough room, and I'm going to fit it. Whether or not we use it, I don't know, but I'm just definitely going to fit it in here. Something like this. Yeah. The idea being, at least if you've got the cartridge and if you pass it over the top and then park it in, pass it over the top, park it in, it should work. So you can see where I'm going with that. It would be nice to hook this up anyway, and then it gets pretty tight again. And when I say in terms of hairiness, you've got that big pin header on the Pi, which we do have to attach our LEDs and stuff to, because I'm going to hook that up on GPIO. But you can see all of those things I want to fit are where that pin header sits. So it's going to be tight, but I think we can get away with it. So I'm just going to work my way through some of these issues, and then we'll check back, see how it all fits together. Update time! I have the RFID reader installed. I flipped its crystal oscillator onto the back so there's a bit more room for it. I've installed underneath this piece of plastic there is that read switch we saw, and you can see the magnet on the power switch. So if I move the power switch, I've got it all hooked up to a test harness. Pleasant. Hot snotted a couple of points here to make sure this stuff just stays put. I made a little acrylic bracket. It's not amazing, you can see, but I've basically glued it one end, and it's to take the strain on the PCB. I won't touch it down there because the glue's still wet. And the idea is so when you push the HDMI in, that board doesn't flex too much because there's not too many anchor points when you mount it into the lid like this. So it's looking like we're almost there, really. It's the next day, having a clear up. Just preparing now the ribbon cable to go from the RFID reader to the Raspberry Pi. I'm not going to be using the pin header on the Raspberry Pi. I'm going to solder directly on the pins because there's really not enough room, and you don't want to be messing around too much taking this in and out. I don't want to damage this plastic of the case. So it's going to be absolutely fine. You can still get to the card, and it's very unlikely that you're going to want to really get into one of these again. Any build I've made in the past, I've never gone back in to mod it. I mean, once they're done really. You've got to choose a time when you build something, or you've got to decide that this is finished. And then you just trim those off like that. Look, boom. Those are nicely tinned, ready to be soldered to that. I've previously just separated these out. Now if you're going to do a proper job, you want to measure these and do it all fancy, you know, everything's spread out nicely. But I'm just going to flare them like that and hopefully get away with it. Go. So far so good. Almost at the point where I'm going to need some tweezers. The old fat fingers. And it's starting to look really nice. I can smell a lovely citrus smell of board cleaner. There. That is totally acceptable in my book. And what I'm going to do, get some of my blue, quite nice this, cheap, it's quite cheap, but cheap blue insulating tape. I'm just going to cut a piece off. And then with that, look, we're done. Isn't that fine? And what you can do, if you want a reference to remind yourself, peel it back. Let's see, which one was the square? That one, closest to me, is the pin one. So you can just write a little one there. You don't forget it. Right, let's do the other end. So after a bit of working out, I've figured out these are the pins on our module here, starting with the marked one next to the crystal, which I flipped onto this side. You've got SDA, SEK, master and slave in, master out, slave in, master in, slave out, IRQ, ground, reset, and 3v3, going from 1 to 8 in that direction. And then on the Raspberry Pi, you've got the pins, as you can see laid out here, going from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way down from left to right, top to bottom. So we want to connect SDA to pin 24, SEK to pin 23, slave in to 19, slave out to 21. We skip IRQ, it's not used. Ground to pin 6, although there are other options for ground. Reset to pin 22, 3v3 to pin 1. And the reason I say there's many options for ground, you've got pin 6, but also pin 6, 9, 14, 20 and 25 are all ground pins, so any of those should do. And while I'm at it, I do have these additional wires. The blue wires are from the reed switch, so they'll go between any of these grounds and pin 16. Now, these two are a little bit kind of a guess right now. I'm going to double check those later, so these could change. So if you're following along, watch the end of the video in case we change those. Those I know will have to be pin muxed and configured to use this. The other GPIO, general purpose IO, we'll just have to use whatever pins are available at the end of the process. I'm hoping these ones will be, because it's just quick for me to solder those and change those if they're not. So as I said, you've got the reed switch going between any of these grounds and pin 16, and then you've also got the LED, the positive coming out of pin 18, which is a switchable GPIO, and then that's going to ground. So rather than using the GPIO as a sink, we're just going to use it as a source. I think it's more than adequate for that. But if you want to do it, you could flip it the other way, flip that diode around the other way, and then reverse its operation, whichever you want. So I'm going to go ahead now and solder these straight on this side. And I'm going to take a tiny bit of care because I don't want too much wire left over, although to be fair, I've got plenty of it, so I could probably wrap a little bit around here anyway for spares in the future. You can see I've soldered all the connections. They weren't great. My solder wasn't reacting well, so it didn't flow as smoothly as it could, but to be honest with you, it's not bad at all really, it's fine. And while I was at it, I noticed that there's two handy test points here. PP2, I think that one was, the 2's a little bit obscured, and PP3. And to that I attached power wires, because this USB port doesn't seem to be an on the go, there's no data capability, it's just purely power. And I attached a piece of wire, and you can see some strain relief. And on the end of that wire is a USB for plugging that in to get power. And just to show you how it all looks, it looks really cool actually. It does look cool. When that's all buttoned up, oops, and I'm not crunching something I shouldn't. So it does all fit quite nicely. There you go. And you can see it just has quite a legit look to it, that little wire. It's gorgeous, isn't it? It's kind of a shame we have to have an HDMI wire as well. So it's almost time to start tinkering really with the software, and while I'm doing that, I'm going to maybe think about putting in a USB connector, just a temporary one, so I can attach a keyboard and mouse to this. I'm not quite sure yet. A lot of the Linux installations on these, once you can access them over the Wi-Fi, you've got no problem, but until you get the Wi-Fi, you've got a bit of an issue. So I might have a look around. We do have another Raspberry Pi 3. Maybe I'll get that up and running and then transfer something in that. Work it out in a moment. So it's looking really good now. I'm going to show you this working with all the software in a moment, but before I do, I want to wrap it all up. And to make it useful, we need to put a Joypad on here and some other things, and I don't have a decent Bluetooth pad to use on this yet, and we're waiting some Megadrive ones to come out. However, I did just get this off Amazon. I'll post a link down below, and it was really reasonable. I think it was like £10 or £15, something cheap. It's actually a keyboard touchpad and generic buttons that you can use right away. I'll leave it off here. And it did come with a nice little dongle that there wasn't enough room. Unfortunately, just not quite enough room in there. However, I have dismantled that dongle. You can see it right there. So it's nice and small. And what I'm going to do is I'm going to actually solder it in here. So looking at the way the wiring would have been, this would have to be that way, so it's a bit annoying. So what I'm going to do is have to just get some wires, and I'm just going to tack them across there, solder that in, and then we'll be able to pop the lid on. So I'll just get the old soldering iron warmed up and we'll do that. Pretty sure this is where I'm going to keep it. So I'm just installing the blast processing unit. Tin the old pads. Ah, lovely, lovely and nice to tin. And work out how you're going to do it. So maybe little wires, little kind or something or another. Not sure. I might try myself using just plain wire interconnects, really. I do like the idea of using component leads because they're sort of, well, not sort of, they are actually very rigid, aren't they? It's a shame it doesn't work out that we could just sort of mount that like that. It's a bit like a mod chip. There, giving it a little bit of extra. So I'm just gonna fold the wire. Oops. Give it a nice orthogonal bend. Yeah, that'll do. Come to me. As pretty or as ugly as you like it, really. It does seem that there's plenty of room in the case too, so even if you're not totally flat with this, there's plenty of room. So I might even put a tiny bit of foam on the bottom of the Raspberry Pi, not in an area where it's going to get heat, so it's nice and snug there in the enclosure. So that's your first one. I'm just going to adjust it now. Yeah, looks good. So mounting it like this might affect the range slightly, but the main idea is that we're going to use the keyboard function, a mouse function of this. We're not using this as the joystick. This is just for configuration, getting the Bluetooth and other functions, because remember, you'll be able to use this as a media center or a file server, or many other things you can use a Raspberry Pi for, and you'll still be able to use it for all those things. So it's just a nice way to do that. Maybe you'll change your Wi-Fi settings. You need to get in and do that. So there's always the odd little thing on a Raspberry Pi that you might want to do, and just the old joystick interface just might not be enough for you. So that's the first two, and then you just need two more. You can see I'm just wiring up exactly as the USB would be normally if you connected it. So if you're in doubt, have a look at the port and get a nice feel for which way around it would have gone. And go forth and experiment. I mean, the worst things you could do is get the power wires wrong on the USB. I'm not sure what that would do. It might blow up your Raspberry Pi, so really take your care on that. And if you're really stuck, get a multimeter out and just check the continuity from the actual USB port to the pins. One more, we're done. Let's get one more little bit of lead. Not sure what project kit I was making which resulted in so many of these legs, but I'm glad I ended up with them. Let's get that nicely tinned. And you'll see by the time you get to this stage that this really won't want to go anywhere. It's like a permanent part of this PCB, but you could glue it if you want. I'm probably not going to bother. I'll rather leave it unglued in case I want to get in there in the future. Okay, just giving it a little push. There's a bit of spring in it, step. So that's ready to go. Pop the lid on. Hopefully through the process you've pretty much figured out how it all works, and what we're going to be doing now is plugging it in and making sure that that Linux now is configured, and I'm going to be just going through some of the interesting parts inside. So that's part 2. Make sure you look for that down below. If you haven't got it, click subscribe, hit the bell icon so you're notified as soon as that video comes out. Respect to the following people who are the patrons who have supported this episode, and of course to Retro Electro themselves for making such a great thing.